Welcome to Opportunity Crude's Management Seminar Series, an informative look at crude processing challenges. Disclaimers. The purpose of the OCMS series is to provide refiners with the latest information in processing opportunity or price-advantaged crudes, such as heavy sour oil, oil sand bitumen, light tight oil, and highly acidic crudes so that they can make better decisions in light of a volatile oil market. Video number 13, Visbreaking is losing traction? Video number 10, What about Bob? Bottom of the barrel, discuss the various methods to upgrade heavy residue into more desirable products. These methods include traditional means, such as solvent deasphalting or SDA, which we discussed in video number 11, coking, which we discussed in video number 12, Visbreaking, and novel conversion processes such as resid FCC or RFCC, resid hydrotreating, and resid hydrocracking. This video will focus on the Visbreaking process. This diagram shows the products produced from each bottom-of-the-barrel upgrading method. The Visbreaking process yields methane gas, naphtha, gas oil, and tar. The selection and operation of a resid upgrading scheme will largely determine the refiner's ability to produce a desirable product slate while processing heavier crudes. This table shows the properties, particularly of the resid fraction, for a number of heavy crude grades from around the world that have API gravities from 10 to 26 degrees. In comparison, conventional crudes such as benchmark Brent of 37 to 39 degrees API and 0.35 to 0.45% sulfur and West Texas Intermediate or WTI of 39.1 degrees API and 6% sulfur have only 9 to 11 volume percent and 6 volume percent of resid respectively. Recent and upcoming mandates have led to a decrease in the demand for heavy fuel oil. The International Maritime Organization's or IMO 0.1% spec for sulfur for fuel used in ocean-going vessels traveling through dedicated emissions-controlled areas has reduced the demand for 1% sulfur fuel oil to the point where the remaining material is simply blended in with the high-sulfur 3.5% bunker pool. Demand is expected to decrease further when the IMO enacts a 0.5% sulfur content spec in 2020. According to the Executive Vice President for Italian Oil and Gas Group ENI, refiners have two options: either buy low-sulfur feedstock or invest in technologies to convert bottoms into acceptable fuels. The conversion of bottoms is a more economical option, and there are a number of methods to do this. Visbreaking is one of these methods. While Visbreaking is not a popular method nowadays to upgrade bottoms, it does have advantages over other methods. This video will discuss Visbreaking in 5 sections. We will first discuss recent news involving Visbreaker additions and trends in global Visbreaker capacity. The video will then discuss some licensed Visbreaker technologies and some commercial additives and fouling control methods for Visbreakers. The section Plant Operational Experiences with Visbreakers will discuss the benefits of online cleaning to remediate problems, namely fouling and coking, that occur in Visbreaker units. The conclusion will recap the topics of the video and discuss a new potential future use of Visbreakers beyond the refinery. This table compares the purposes, conditions, and methods of Visbreaking with delayed and fluidized coking, showing the differences between the thermal cracking techniques. Register today to attend the upcoming 6th Opportunity Crudes Conference in Houston, Texas from October 22nd to the 24th. Hosted by Hydrocarbon Publishing Company. The theme of the conference is Crude Disruptors, Accelerating Changes in Global Refining. Visit OpportunityCrudes.com/Houston 2018 today to take advantage of the early bird discount. Thank you and see you in Houston. Here is the agenda for the 6th Opportunity Crudes Conference. There are 5 topical sessions. Session 1, Global Oil Market Outlooks, Geopolitics, U.S. Pro-Export Policy, OPEC Strategies, Peak Demand. Session 2, Challenges and Opportunities in Oil Trading, Exports, Imports and Infrastructure Logistics. Session 3, Crude Contaminants, Incompatibility, Blending Strategies Amid Changing Feedstocks. Session 4, flexibility of light tight oil processing and bottoms upgrading to make products in demand, and Session 5, big data analytics and emerging adoption of Internet of Things in crude selection. This table shows total visbreaking capacity reported in 2018 and 2013 in the regions of the US, Canada, Latin America and the Caribbean, Western Europe, CIS and Central and Eastern Europe, the Middle East, Africa, and Asia and the Pacific, as well as worldwide totals. In the 5-year period, worldwide visbreaking capacity dropped approximately 17% from levels reported in 2013. Almost all regions reported drops in visbreaking capacity, with virtually all capacity being eliminated in Africa. Only in the Canada region did the amount of visbreaking capacity increase. In 2018, Western Europe reported the highest percentage of visbreaking out of total capacity at 8.18%. Based on U.S. Energy Information Administration data since 1987, U.S. visbreaking levels, almost all of which reside in the PAD 5 region, has steadily declined. The peak level was at 346,000 barrels per day in 1988 and then began a precipitous decline to 16,000 barrels per day in 2007. In the last 11 years, the rate remained the same at 16,000 barrels per day. In 2018, Polish refiner PKN Orlen announced plans to build a new visbreaking unit at its 330,000 barrel per day Plock refinery. PKN Orlen said the new visbreaker will boost distillates output by 1.2 thousand metric tons per day or 9,000 barrels per day while reducing high sulfur fuel oil output. The new unit is expected to be online by the end of 2020, which would help the refiner comply with the International Maritime Organization's new sulfur spec. In 2015, Paris-based Technip and Japanese engineering consultancy Unico received a project management consultancy to upgrade Iraq's Basra refinery to boost gasoline output. Part of the upgrade includes visbreaker installation. Also in 2015, Russian Rosneft installed visbreaker capacity in its Kuybyshevsky refinery. According to OPEC's World Oil Outlook 2017, over 11 million barrels per day of secondary refinery unit capacity, which include visbreaking, will be added around the globe from 2017 to 2022. Most of this new capacity will be centered in Asia Pacific, the Middle East, and Russia, where growing demand and the introduction of tighter fuel standards are driving investments in secondary unit capacity. Over 1 million barrels per day of coking and visbreaking capacity will also be added, with the new IMO spec also being the main driver. McFoster Wheeler UOP offers its coil-type visbreaking process. Their coil-type visbreaker has been claimed to have the following advantages: reduced high-sulfur fuel oil output, a reduction in distillate cutter stock requirements, which makes the distillate available for sale as more valuable transportation fuels, a low cost to upgrade, and a simpler maintenance and decoking compared to soaker visbreaker designs. These coil-type visbreakers can be integrated with vacuum units to eliminate redundant equipment and reduce installation costs. This type of integration was evaluated for a Russian refinery designed to operate a new vacuum unit along with a visbreaking unit. This process diagram shows a McFoster Wheeler UOP's coil-type visbreaking process. Key features include 2-zone horizontal type fired heater with soaking coil, high furnace outlet temperatures, short reaction times, quenching of heater effluent with gas oil, fractionator bottoms, or a combination of both, proprietary heater valves and piping arrangements for longer run lengths, and optional integration with vacuum units for reduction of installation costs. A McFoster Wheeler UOP also offers visbreaker with vacuum flash. In this option, the visbreaking unit is configured in the same way as the basic coil visbreaker, except that the bottom stream from the fractionator is sent to a vacuum tower. The liquid that exits from the bottom of this tower is steam stripped, while the vapor overhead is partially condensed into distillate products that can be processed to transportation fuels. Heavy vacuum gas oil and light vacuum gas oil side streams are removed from the column and combined. Part of the combined vacuum gas oil product is used for fuel oil viscosity reduction, while the remaining portion is utilized as cracker feedstock. This process diagram depicts a McFoster-Wheeler UOP's Visbreaker with vacuum flash. A McFoster-Wheeler UOP's two-stage Visbreaker is similar to the Visbreaker with vacuum flash, except that the combined gas-oil stream is sent to a thermal cracker before being routed back to the fractionator. The company claims that benefits of the two-stage Visbreaker are that the yield pour point of fuel oil are reduced and light distillates yield is increased. The yield of heavy gas oil distillates may be enhanced by sending the tower stream to the vacuum tower. This process diagram depicts a McFoster-Wheeler UOP's two-stage Visbreaker. Another innovation available to adjust the configuration of a McFoster-Wheeler UOP's Visbreaker offerings is Wood's technology. According to a McFoster-Wheeler, Wood's process offers several benefits, including a 10 to 15% reduction in fuel oil output, the ability to reduce the fuel oil viscosity and increase fuel oil stability by blending light and or heavy cycle oil into the Visbreaking residue, and the production of higher quality high vacuum gas oil feed for FCCUs and hydrocrackers compared to Visbreaking with a vacuum flasher. Axon's proprietary Visbreaking technology is called Terval. In general, this process increases the residue value by reducing the viscosity of the heavy feedstock by mild cracking. Terval maximizes gasoline and middle distillate products when applied to atmospheric residue feedstocks, with consideration for the residual fuel oil specifications for viscosity and stability. When the feedstock is a vacuum residue, the process is applied to drastically reduce the viscosity to produce commercial fuel oils, with the addition of a light diluent, if needed. Axons offers three variations of its Terval process: Terval T, Terval H hydro Visbreaking process, and Terval C. Here is a process diagram of Axon's Terval T process. It is said to achieve vacuum resid conversions of around 38%. This diagram shows the process configurations of Terval H and Terval C. The Terval H hydro Visbreaking process increases conversion by about 10% over Terval T and achieves a greater reduction in product viscosity. Terval C, which is configured in the same way as Terval H, uses 50 parts per million of an ultra-dispersed molybdenum additive to increase hydrogen efficiency and produce a stable product. Other benefits include a 40+% conversion and a further drop in resid viscosity. According to KBR, their Visbreaking technology boosts distillate production while reducing heavy fuel oil output by 25%. KBR also offers a soaker Visbreaking process, which uses longer residence times and lower reaction temperatures. Although the soaker process prevents heavy gas oil product from being recovered, it beneficially lowers the heater fuel requirements. In addition, the company has developed techniques for recycle cracking of Visbreaking gas oil and special design methods to determine furnace and quench parameters such as cracking severity and soaking coil volume. This diagram depicts KBR's Visbreaking process. ABB Lummus Global licenses Shell Thermal Conversion Technologies, which includes Shell Soaker Visbreaking technology, Shell Deep Thermal Conversion, Shell Thermal Gas Oil Process, and Shell Deep Thermal Gas Oil Process. Additionally, Shell Vacuum Flash technology can be added to Visbreakers for additional benefits. The goals of the Shell Soaker Visbreaking technology process are to reduce the heavy oil product by lowering the viscosity of the resid and to maximize production of distillates. The company claims the technology has the following benefits: high tolerance to feedstock changes and operating upsets, enhanced process control, extended heater run lengths, faster turnarounds, and lower power requirements due to the low pressure drop in the heater and generally mild operating conditions. This process diagram depicts the Shell Soaker Visbreaking technology. In the Shell Deep Thermal Conversion process, the bottom stream from a vacuum flasher can be obtained and used as gasifier feed. There are a number of additional benefits according to the company. The process does not require a coke handling system. Also, Shell Deep Thermal Conversion process utilizes the hydrogen in the feed to produce higher quality distillates than the products obtained from delayed coking. Finally, the distillate yield from this process, which ranges from 45 to 60 weight%, is higher than that from traditional soaker visbreaking due to the conversion achieved and the use of the vacuum flasher. This diagram depicts the Shell deep thermal conversion process. Shell offers both the thermal gas oil process and deep thermal gas oil process. In Shell's thermal gas oil process, the company's patented soaker visbreaking, vacuum flashing, and thermal cracking are utilized to yield distillates. Also, the cracked residue stream that exits the bottom of the vacuum flasher is commonly used to produce commercial fuel oil. The Shell deep thermal gas oil process uses more severe operating conditions to produce liquid coke. This process is said to have conversion levels of 50 to 60%. This process diagram depicts the Shell deep thermal gas oil process. Baker Hughes VisTech program includes two methods for reliable assessment of visbreaker tower stability for fouling control. The VisTech Stability Index provides results that are more accurate by relying on a near-infrared-based probe instead of operator judgment. The patented VisTech Coke Index is calculated using a coke particle counter sizer and provides a measurement of the tendency for coking to occur in the furnace. Additionally, proprietary chemical additives can be applied to mitigate the feed-based constraints of the unit, particularly when operating severity is increased in an attempt to increase conversion. These chemical additives include asphaltene dispersants, asphaltene stabilizers, and coke suppressants. GE Infrastructure Water and Process Technologies, now a part of SUSE, has conceived a 7-step program called VSTAR. The program analyzes the specific needs of the target visbreaker, identifies and quantifies specific parameters, determines the objectives to be met, and monitors to provide parameter adjustments as needed. Also, chemical additives are applied to limit fouling and improve operations. The tools of the program include modeling and regression analysis and statistical process control. Nalco Champion has developed the Conversion Plus 2 programs so that refiners can safely monitor and control fouling in visbreaker units in order to optimize unit severity and, accordingly, maximize conversion. The Conversion Plus 2 optimization system comprises the steps of surveying the visbreaker unit, analyzing potential feeds, designing a chemical additive package using a simulation unit, and monitoring operations to identify key constraints and continuously adjust operating conditions. There are important considerations when using visbreaker units, mainly fouling and coking in furnace tubes and atmospheric and vacuum fractionators associated with visbreaker units. While there are techniques to monitor coke formation in visbreaker units, the best practice is to regularly clean the units to remove coke. In this video, we will discuss online cleaning of visbreaker units. Regardless of the steps taken to limit the rate of fouling and extend heater run lengths, equipment utilized for severe thermal processing will require regular cleaning. Coking of visbreaker furnace tubes and heat exchangers leads to a decrease in energy efficiency and may also reduce the life of the equipment. However, the economic losses due to increased fuel consumption are dwarfed by those related to frequent and extended unit shutdowns that result in a loss of throughput. As a result, refiners will often put off scheduling regular maintenance and cleaning activities until absolutely necessary, sacrificing some level of efficiency to keep the unit and stream as long as possible. Also, traditional cleaning methods carry a number of health and safety risks for refinery workers, and the physical removal of coke can result in the release of harmful particulates to the atmosphere. In many cases, online cleaning is implemented when traditional cleaning methods are ineffective. However, these methods may also be applied during more traditional turnarounds to hasten cleaning activities. Online cleaning reduces the problem of refinery workers being exposed to hazardous conditions, and eliminates other potential problems associated with the physical cleaning of refinery equipment. A representative from ITW has presented the merits of employing closed-loop online cleaning techniques in visbreaker bottom sections and in visbreaker heat exchangers. This table compares 3 furnace coil cleaning methods: pigging, online spalling, and steam air decoking. The function, technique employed, use when the furnace is either online or offline, safety concerns, effluent generation and disposal, operating personnel, efficiency, and furnace run length of each method are shown. This table shows the advantages and disadvantages of both the offline and online methodologies of spalling and pigging. Refinery Visbreaking offers refiners an option to enhance residue conversion with moderate capital investment compared to alternative conversion processes. However, with the growing demand for lighter products and subsiding demand for fuel oil, the role of the visbreaker in a refinery has been minimized. IMO's new sulfur regulations and competition from other sources of fuel such as diesel and liquefied natural gas further decrease demand for fuel oil, casting even more doubt over the future viability of the visbreaker. In fact, the past 5 years have seen a trend of decreasing visbreaking capacity as refiners look for other residue upgrading methods. While refiners may be interested in more profitable residue upgrading methods, integrated processing schemes, optimization, hardware, and fouling control including the use of chemical additives are all available to enhance the profitability of the visbreaking unit. Additionally, while the visbreaker may be falling out of favor within a refinery environment, it may see some new applications in being applied for in situ upgrading of very heavy crudes at upstream oil fields such as those in the Canadian oil sands and in the Orinoco Belt in Venezuela. In fact, recent research has looked into new visbreaking innovations designed for in situ upgrading of heavy crude right at the production field. So while downstream refining applications of visbreaking may be dwindling, the technology may find some renewed life in upstream projects. Thank you very much for watching our video. Please join us in August for our next seminar, video number 14, Resid FCC, Getting to the Bottom. Sponsorship opportunities are still available for the rest of the seminar series. Please contact Matt Wonder at mwonder@hydrocarbonpublishing.com to sponsor a future video. Sign up today to receive our quarterly technology newsletter, Worldwide Refinery Processing Review. Since it was launched in 1998, the review has become the most authoritative and comprehensive publication of the latest refining technologies around the world. The review monitors commercial technology developments and competition, plant operation improvements and troubleshooting, and R&D trends for all processing units, from the front end to the back end, in a single source. Each issue covers 2 technology topics with the following sections. Market and Technology Trends and Opportunities offers a strategic overview of the featured technologies. State-of-the-art technology. Plant Operations and Practices. Refining R&D Alert, which has extensive coverage of the latest patents and analysis as well as research work undertaken. Worldwide Installed Capacity. Recent construction activity and completed construction projects and latest refining technology developments and licensing. As shown in the table, this year's subscription will cover 8 topics, 2 in each quarter. Apart from an annual subscription of the review, individual quarterly issues and individual technology topics are also available for purchase. For more information, contact us at review@hydrocarbonpublishing.com. Your comments are appreciated. Please send your comments to info@opportunitycrudes.com so we can enhance the value of upcoming seminars. Here are upcoming crude oil quality events. Disclaimers.